This next one here, we're asked to integrate x squared over x to the fourth minus 1 dx. So here we're fine in that the degree of the numerator is less than the degree of the denominator, and we can factor the denominator. When we factor the denominator, you get x squared plus 1 times x squared minus 1, and x squared minus 1 can be further factored as x plus 1, x minus 1. So we do have two linear factors. However, the x squared plus 1 is an irreducible quadratic factor. I cannot factor this and have real numbers. So we're going to have one quadratic factor. So this one's going to be a little different because of that quadratic factor. The way we set up the partial fractions here is going to be slightly different. So I'm going to have the x squared over this whole denominator. And over that quadratic factor, I'm going to do ax plus b. And then I'll put a c over the first linear factor and a d over the second. And now I'm going to do just like I've done before. I'm going to multiply through by the common denominator, the x squared plus 1 times x plus 1 times x minus 1. And when I do that, I'm left with x squared is equal to ax plus b times x plus 1, x minus 1, plus c times x squared plus 1 times x minus 1, plus d times x squared plus 1 times x plus 1. So there is a lot more happening here. Now, there's a couple ways, again, that you could approach this. You could multiply everything out and then sort out, when you multiply out, you'll have x cubed terms, x squared terms, x terms, and constant terms. And you can sort those out, and you end up with an equation of 4 equations with 4 unknowns. In my written notes, I went ahead and worked it out that way, just in case anybody's interested, wants to see how that works. But we can also use the shortcut, and that's what I'm going to do here for the example. What I'm going to do is I'm going to start out by letting x equal 1. And if x equals 1, then this ax plus b times x plus 1 times x minus 1, that whole thing is going to go to 0 because 1 minus 1 is 0. So it wipes that out. Same thing here with the c. 1 minus 1 goes to 0. So I'm just going to be looking at what's on the left-hand side of the equals and the part here with the d. So if x is 1, 1 squared is 1. And over here, 1 squared is 1. 1 plus 1 is 2. 1 plus 1 is another 2, so I get a total of 4d. So that tells me that d equals 1/4. Now I'm going to do something very similar. I'm going to let x equal -1. And if x equals -1, the first bit here with the a and the b, that's going to go to 0 again because -1 plus 1 goes to 0. And the part here with the d will also go to 0. So that just leaves me this here with the c. So -1 squared is 1. -1 squared is +1. 1 plus 1 is 2. -1 minus 1 is -2. When we multiply, we get -4c. So c is -1/4. Okay, we're getting there. Next, I'm going to let x equal 0. By letting x equal 0 is going to eliminate the a term, because a times 0 is going to be 0. So what does that leave me with? Well, it leaves me with 0 equals. I'm going to have b here, because remember this a term goes to 0. 0 plus 1 times 0 minus 1, that's going to give me a negative 1b. Then I have 1 times negative 1 in front of c, so that's going to be a negative c. And then 1 times 1 plus d. So if I bring the b over to the left, I get a positive b is equal to negative c, so that's negative 1/4, plus d, which is positive 1/4. Well, the two negatives here make a positive. 1/4 and 1/4 give us a 1/2 for b. Now, we still need to go back and find a value for a. Using this method to go and find a, you can let x be whatever you want. I want to keep things simple, so I'm going to let x equal 2 here. There's not really a secret strategy for this last one. So if x equals 2, 2 squared is 4. I've got 2a, okay. 2 plus 1 is 3. 2 minus 1 is 1. So 3 times 1 is 3. So 2a times 3 is 6a. Then I have b times 3, which will be 3b. And I'm going to replace that with the 1/2 in just a bit. Moving down the line, 2 squared is 4. 4 plus 1 is 5. 2 minus 1 is 1. 5 times 1 is 5, so I have 5c. Then for d, I'm going to get 2 squared plus 1, 5, times 2 plus 1, 3. 5 times 3 is 15d. So 4 equals 6a plus 3 times 1/2 plus 5 times negative 1/4 plus 15 times positive 1/4. I'm running out of space, but I think I can make this work. So 4 is 6a. 3/2 is the same thing as 6/4, so I'm going to write it that way. So I have 6/4 minus 5/4 plus 15/4. If you add up these fractions, you're going to get 16/4, and 16/4 is 4. So 4 equals 6a plus 4. Means that 0 equals 6a, or that a is 0. So now I have values for a and b and c and d. So I can go ahead and write my x squared over that big denominator as a series of these partial fractions. And we've done the hard part. That actually was the hardest part of this problem, and we finished it. So I mentioned in another example that you could write this as, with one big integral, or you could break them up. It really doesn't matter. I'll break this one up just to do something a little different. So for my first fraction, a is 0, b is 1/2, so I'm going to integrate 1/2 over x squared plus 1 dx. Moving to the c, that's a negative, so I'll do minus. And then we've got 1/4 over x plus 1 dx. and then d is positive a fourth over x minus 1 dx. Now, the second and third integrals, those are going to be natural logarithms. The first one, and you may need to go back to your integral table for this, but this is going to integrate at least the 1 over x squared plus 1. The 1/2 will be in front. That's inverse tangent of x. So we end up with 1/2 inverse tangent of x. Then we'll have minus 1/4 times the natural log of the absolute value of x plus 1 plus 1/4 times the natural log of the absolute value of x minus 1. And then since this is an indefinite integral, we have r plus c. If you want to, you could combine the two natural logarithms, but I'm actually happy with this as is, but I do in my written copy of the notes, I do have them combined if you want to see that as well.